I hope all of you are doing good. Let's start today's chapter. Pictorial representation of data. Data collection, recording and representation. In our day-to-day life, we collect various numerical facts such as number of students in each class, number of students from each house, marks obtained by students in a particular test, etc. These numerical facts are called data. A data is a collection of numerical figures gathered initially to give some information. Example, suppose a teacher wants to know how many students from each of the houses, that is red, blue, yellow and green, are there in the class. Okay, data collection. She calls out a child's name as per the list in the attendance register and notes down the house of each child. This is the process of collecting data. The information recorded is as follows. Okay. This way of recording the information is still difficult to tell the number of students in each house in one glance. Okay. So telemarks is a more systematic way of recording data. The data can be recorded as, which is given here. Okay. For each child, only one telemark is drawn against the respective house. 4 telemarks are drawn as 1, 2, 3, 4. And the 5th telemark is drawn as a slash crossing the 4 marks drawn earlier as like this. We cannot show 5 as 1, 2, 3, 4, 5. This is wrong. 1, 2, 3, 4 and 5. Okay. This represents 5 counts. This way of counting 5 together is easier. The telemarks are counted for each house and their numbers written in the column number of children. Check the sum. The sum is what? 40, which should match with the number of children to avoid any mistake in counting. From the tally table above, we can quickly make out the number of children in each house. We can find there are 7 children in red house, there are 12 children in blue house, 13 children in green house and 8 children in yellow house. The maximum number of children are in green house followed by blue, and the minimum number of children belong to red house. Okay. Now, a representation of data. After collecting the data and recording it systematically, it is represented in a form that is understood at a glance. The data may be represented in many ways called graphs. Okay. Pictograph, which we have studied earlier, and this is bar graph and this is pie graph. Okay, or you can say pie chart also. Example 1, the following table shows the number of notebooks available in a bookshop. Okay, subjects are given here and a number of notebooks are given here. So we have to represent it by pictograph and then we have to answer the following questions. First, we will represent it as like this. Here one book represents 100 notebooks, means for 600 notebooks we will draw 6 notebooks. For 300 notebooks we will draw only 3 notebooks. For 500 we will draw 5 and so on, right? Now, question is, how many notebooks are available in the bookshop? How many notebooks means you have to add all these notebooks. So there are total how many? 2000 notebooks. Okay. B, which notebooks are available the most? Most, as you can see, English. Okay. C, which notebooks are available the least? Least is social studies. And D, how many more English notebooks are available than Hindi notebooks? Okay, so English notebooks are 600 and number of Hindi notebooks 300. We will find the difference of both. So 300. Okay, right? Exercise 27.1. The following table shows the houses of students in a particular class. Represent the above information by pictograph using this figure for 2 students. Okay, means you will draw how many figures here? 6, here 7, here 5 or here 9. Okay students, now answer the following question. What information does the pictograph give? This pictograph depicts about the house of the students in a particular class. Okay. B, which house has a maximum number of students? As you can see, which house has a maximum students? Yellow. See how many students are there in the red and yellow house together. In red house there are 12 students, in yellow house, okay, red and yellow, there are 18 students. So total students 30, right? And which house has the minimum number of students? As you can see, green house has minimum number of children, number of students. Okay. Now bar graph. The above information can also be represented in the form of a bar graph. We can see bar graphs almost every day in the newspaper and television. In a bar graph, the data is represented by rectangles called bars of equal width. These bars are drawn vertically or horizontally with equal spacing between them. The length of the rectangles depends upon the numerical data it represents. The length of the bars are drawn as per scale. Just as a picture in a pictograph, there is unit length. Example 1 centimeter in bar graph, which represent a fixed number of objects. The relation between the unit length and the number it represents is called the scale of the bar graph. Okay, so here scale has been chosen as 1 centimeter is equal to 2 students. Usually the scale is mentioned in the graph. For example, here 1 centimeter is equal to 2 students. We can choose any scale to make the graph to fit the size of the paper. Okay, OX and OY are two perpendicular rays that meet at O. Okay, this is OX, this is OY. Okay, this is also known as x-axis and y-axis. Okay, on x-axis we have taken colors name, and on y-axis we have taken the number of students. Okay, horizontal ray OX is called x-axis and vertical ray OY is called y-axis. The houses are represented on OX and number of students on OY. The width of the bar is uniform and should be uniform throughout the graph. Okay, the distance between the bars is equal throughout. Example 1, given below is a tally chart. Study it carefully and answer the question. Count the tally marks and fill in the columns number of clothes. Okay, so sweaters, how many sweaters are there? 5 plus 5 plus 5, 15 plus 2, 17. Caps 10, shawl 11 and jackets 9. What type of clothes were sold the most? Most sweaters. What type of clothes are sold the least? Least number jackets. And how many shawls were sold? As you can see here, 11 shawls sold. Okay. Exercise 27.2. From the given information, answer the following question. A fruit seller recorded the number of leftover fruits in his shop after a day's sale as follows. Okay. So number of bananas, 5 plus 5 plus 5, 15. Orange, 5 plus 5, 10 plus 1, 11. Apple, 5 plus 4, 9 and guava, 2. So how many fruits were left in all? What will we do? We will add all these fruits, that is 15 plus 11 plus 9 plus 2. Let's add 9 plus 2, 11 plus 1, 12 plus 5, 17. 1 carry, 37. That means 37. Which fruit was left the most? Which fruit left the most? As you can see, banana. How many oranges were left? How many oranges were left? 11. Which fruit was left more? Guava or apples? Obviously apples, because number of apples are more than guava. So apples. Okay students. Now you will do practice of the remaining questions.